Hello, everyone, and welcome back to E-Channel News. And I'm your host, Paulo Dunley-Bledo. We talk a lot about AI, and we continue to talk a lot about AI. But what about all those legacy systems out there? Do they have a role to play in the AI world? Here to talk about this and a lot more is Jim Piazza, the Chief AI Officer for Ensono. Ensono is a Chicago-based global managed IT and hybrid cloud services provider that helps enterprises modernize legacy systems, migrate to the public cloud, and unlock all that potential of AI. Jim, welcome to the program.
Thank you so much. It's great to be here.
Great to have you. I remember when I started my career, got invited to this IBM conference in one of those IBM towns. I can't remember. There's so many of them in upstate New York. And they launched this mainframe. And I remember the sticker shock of $31 million. I'm thinking, wow, that's crazy. I wonder, is that system still like around these days? And how do you look at modernizing mainframes and trying to transform those legacy systems into the AI era?
Great question. And the answer to your first question is yes, they're still around. The Fortune 500 still loves their mainframes. And I mean, we work really closely with IBM and specifically, the Z series mainframe and the Power series devices that they create and many of the Fortune 500 operate still run a lot of the core systems that we have as a nation today. When you think about credit card transactions and things like that, those all still run through those incredibly powerful systems. So the backbone of a lot of the economy still relies on a lot of sort of the big IBM hardware. On to your second question around how do you modernize that, coming at this from an AI perspective, you said it best. AI is kind of everywhere. We talk about AI in our daily lives, our personal lives, you name it. And the same is true, of course, across companies in the U.S. and abroad. So the whole premise behind this, I think, is with AI, the only thing you do with bad data is make poorer decisions faster. So regardless of what the hardware platform is, we're still all relying on the data. Now, what do mainframes have? They have gobs and gobs of data. And so how do we make best use of that comes in kind of a couple different buckets. One, the area where I'm most sort of focused on is around the operational piece. Mainframes are not unlike any other system where they have issues, faults, errors that happen. And so how do we get in front of those and actually start to predict when things are going to happen? Think of it like a really cool IT weather forecast kind of thing.
Okay.
That's one bucket. And then the other bucket is around how do we modernize the sort of the business operations today? If I'm a credit card company, like we talked about, how do I use AI to help prevent fraud? How do I use AI to make sure that my transactions are running through smoothly and that customers are getting, credit check applications back, in microseconds versus milliseconds? There's things that we can do to sort of modernize that. But that's sort of my perspective at the 100,000-foot level.
So you also do some great work with cloud migrations and managed services, and the buzz there in the channel is always reducing the IT costs, the managed workloads across AWS, Azure, other hybrid environments. What are you trying to do there to try and ease that burden for the channel?
Yeah, great question. And we do see some customers who say, you know what, I really want to move off of the mainframe. And that's certainly something that we can help them with as well. So we have done, sort of migration from the old IBM hardware to cloud systems. And we have seen hybrid approaches as well, where people are like, hey, you know what, I just want to update my COBOL application that runs in my mainframe. And I want to modernize the app into something that the programmers of today are used to working in, a la Python or something like that.
Right.
The part of the challenge that we see, quite honestly, with the mainframe in a lot of cases is, folks got really comfortable coding in COBOL, 20, 30 years ago, But if you try to find, COBOL programmers that are coming out of college today, they're a little harder to find. So
Mm.
that's another sort of modernization aspect that we see customers asking us for. So that's, move off of the mainframe to cloud, modernize my application on the mainframe, help me run the business more efficiently, help me predict failures before they actually occur. Those are the sort of the big bucket items.
I want to get your take on regulatory industries. And you mentioned earlier about having good data, and obviously that's essential. But what about predictive analytics from the machine learning capabilities for these specific industries? What's your take on that?
So my take is that there's been a significant amount of data engineering work, and like if you think about the path to getting machine learning in place for an organization, again, we all know this. It starts with the data, but there's a certain amount of data engineering work that has to happen up front, and that includes what we call ETL in the business, or extract, transform, and load.
Mm.
And so we have to figure out how do we get at the data? That's the extract piece. Then we have to get it into a shape that makes sense for us to use a machine learning algorithm on. And then we also have to be able to load that into a model, build a training data set, and then inference against that training data to actually get the model to sort of run in production. And so, regardless of the platform that we're talking about, mainframe, power, cloud, whatever, those are the steps. Now, what data you actually go and use to harness your sort of predictive intelligence, that comes from things like syslogs, and it comes from things like JCL logs on the mainframe, or SMF records on the mainframe, or any of the server telemetry data that you get off of your monitoring systems. That's what you use as sort of your baseline to actually get that data.
So let's get your global perspective on a few issues. There's definitely surging energy issues, wars on two main fronts, all having an impact on AI data centers. How do you assess the situation currently?
So on the power side, the let's put it this way. I'm going to back up for a second. The demand for AI is real,
Mhm.
and I've heard people, people have asked me in the past, do you think we're in a bubble? And I'd be careful calling it a bubble because the demand is real. However, if we think back, and I'm going to date myself here a little bit, if we think back to the dot-com era, was
Mhm.
the internet a bubble? Sure.
Oh,
Was
yeah, it
there a
was
pullback?
real, but it was a bubble
Yeah.
too.
That's right. That's right. And I think we're seeing the same cycle play out again here.
Okay.
So will there be M&A? Will there be pullbacks? Yeah, probably. But if you think about where the internet is today from an importance standpoint on everyday humans' lives, I think it's way more important today than it was even back in the early 90s, early 2000s, when the bubble was forming, and eventually we saw that pullback. So with all that said, on the energy front, yeah, and the demand for energy continues to rise. I've seen some things where, data centers are definitely getting, I think, some bad press. And having worked at hyperscalers and managed services providers in the past, I can tell you this, they are committed to making sure that they are investing in renewable energy, which I think is super important. And then there's the water usage component for data centers. And it's not like modern data centers sit there and pull from the well, groundwater continuously, right? They're closed loop systems that use a portion
That's
of
right.
their cooling as water, but they also use glycol mixed in with that to keep the water treated. So it's not like they're placing the extraordinary demands on water. I think the power demands are something that's more significant right now, and that's why the investment in renewable energies is so important.
So I got this factoid on AI hardware. Wanted to put it by you, get your take on it. So AI hardware, 2 to 3 year obsolescence cycle versus 5 to 7 for traditional IT. Um, but they're not really a depreciated asset, right? If you look at it, um, when you hear that, like, what's the first thing that comes to your mind?
I think the first thing that comes to my mind is that the cycles are shortening, that the pace of innovation on specifically on like the GPU side of things, I think has shortened the traditional cycle. To your point, I think enterprises have been operating in that 5 to 7 year depreciation cycle for decades. The hyperscalers never really operated in that space, to be honest. They always started off, even on the traditional CPU side of things, with shorter depreciation cycles, 2, 3 years tops. So they're sort of more used to it. In fact, I think they've been gravitating more towards the enterprise side of
Mhm.
things and trying to extend that. The problem is that the pace of innovation is so great and so fast on the GPU side of things, they have to sort of keep investing in the latest and greatest if they want to keep up and stay competitive. There's some really interesting developments, I think, that are coming down the road as it pertains to sort of the next generation of GPU hardware. One thing that I've become really interested in lately is the idea of photonics. If you've heard of that,
Yep.
there's a couple of companies that are working on sort of replacing all the copper that you think of when you think of a modern day server with photonics versus copper, and that does two things. It saves on the cost to go mine the copper, put it in place, and build the system itself. But I think more interestingly for me is it completely drops the cooling requirement for modern day servers. So, if you replace all the copper in a server and you put in, say, you use light based, 90% of your cooling has just gone away, which is going to also reduce your energy consumption long term in the data centers.
So while GPU, memory, power infrastructure costs have spiked recently, a lot of that looks like demand shock rather than a permanent baseline. Do you see it the same way?
I do think that it's demand shock. I just don't know when the demand is going to stop because it seems like day over day it keeps growing, or at least keeping pace. What's another interesting thing that I think people often overlook is like if you think about DeepSeek, right, from a pure foundational model
Mhm.
perspective, DeepSeek was not trained on the latest and greatest hardware. It was trained on a few generations of older NVIDIA hardware. And so that was done through clever software engineering. I think what we're going to start to see is as the hyperscalers continue to get pressure on the investments that they're making, they're going to have to think of clever ways to do similar things. And some of that I think is starting to proliferate out into some of the other foundational model developers, where they may not need the latest and greatest hardware that they can run on a generation older, which is a huge savings from a capex perspective, as you know.
I did not know that. Thank you. There's another move afoot, sort of shifting gears to like the huge potential of small language models. Not every problem needs to be solved by a massive, model. So it sort of it looks like they're working to reduce the pressure on memory on the memory chip shortage, which is a real issue. Do you see it that way as well?
Yeah, it's funny. A few people have asked me about this too. I think that we're about to see the rise of small language models more so than ever before,
Mhm.
and sort of the enabler for all of that is like things like MCP or A to A, as an example, where we can have small language models that work together to solve problems versus having one monolithic sort of LLM that's out there. I mean, at some point, you're going to hit economies of scale where trillion parameter models will make sense. Don't get me wrong. I think there's always going to be a need for them. But from a business and an enterprise standpoint, do I really need to go leverage a trillion parameter model? Or can I put together, I don't know, 5, 6, 10 small language models, wire them up together using MCP and go solve the business problems that I'm after using that? In fact, you can almost think of it like an app store, right? Apple's app
Yeah.
store.
Let's talk about Ensono for a little bit. What's
Hmm.
your go-to-market strategy?
So we are on a quest to become the world leading AI first managed services provider. As you know, I've done your research. We support several very large clients. We're not out to solve problems for everybody, but for the customers that we have, we are looking to modernize not only our efforts but help them on their journey as well. So I came into Ensono a couple of years back. I came from Facebook, actually. I worked at Meta for almost 10 years. And while I was there, we built systems that helped Meta scale their operations over time. We're doing the same thing for Ensono. And so we want to have sort of this really robust, scalable, and agile MSP that leads with AI first. And that's what our go to market strategy is.
So is it sort of similar to like maybe 10 years ago where there with cybersecurity where there's development of MSSPs?
Mm-hmm. Yeah, it's sort of similar in that regard. I mean, we support everything from, as you know, mainframes to distributed systems
Mhm.
to network applications and all the plumbing that goes in between. And our customers trust us to outsource their operations to us because we can do it at scale. We've got all the core enterprise systems, we've got the talent, and now we're bringing AI into all of those different sort of verticals and aspects of running a really complex IT shop to provide that at scale securely.
So is there a play for other MSPs to partner with you?
I mean, potentially, we have a variety of different types of clients across different types of verticals. So I would never leave anything out. But I think most, a lot of our business revolves around the Fortune 500 and beyond.
Right.
So wherever they happen to play.
Okay, cool. Let's talk about you a little bit, Jim. What are some of your likes and dislikes? It doesn't have to be, business related. Could be personal, but what makes you tick?
What makes me tick? I'm at heart, I'm a data person. Like my
Mhm.
fiance laughs at me all the time because she's like, you need to have access to all the data so that you can decide what's important and what you want to pay attention to. I don't know if that's a flaw or a benefit for the job I have, but she's still with me. In my spare time, I like to code, so I code in my spare time. We recently just got back from Italy. Great trip. Had a blast, and it was a good reminder for me that spending too much time behind the screens is never a good thing. Like it's really important to go out and touch grass and go experience different cultures and history, which is always interesting to me as well. So a little bit about what makes me tick.
Well, there's no place to do that better than the Eternal City there in Rome.
Gotcha.
Do you actually use data models to like select a restaurant or a bar or a night spot or a rooftop or something like that?
I'm not gonna lie, I may have used ChatGPT to help plan the itinerary a little bit.
I'm not sure if the Italians are up to snuff on that. Being Italian myself, they tend to lag a little bit behind as a culture, but I still love them, right?
Yeah, yeah, yeah.
So fantastic! I really appreciate your time and all your insights on this, Jim. Where can people learn more about Ensono? Where can people follow you?
Sure. Yep. The usual platforms. So you can find us both on LinkedIn. You can find me by name. I try to post as often as I can, just with thoughts and things like that. Try different formats and all that. You can also find Ensono on there, or you can go to our website at www.ensono.com.
Fantastic. Well, there you have from Jim Piazza of Ensono. Thanks again for watching eChannel News. Until next time, I'm Paul Donley Bletto. So long.